Actually, I want to circle back. So the Mid-Atlantic Ridge is actually the North Atlantic continent trying to separate from the European continent. Is that correct?
Yeah, exactly. Yeah, it's those plates moving apart from each other, and also South America moving away from Africa as well.
So really, these volcanoes are just kind of everywhere because you mentioned they're also in subduction zones where tectonic plates are colliding and one's going underneath the other.
Yeah, volcanoes are everywhere, and a huge percentage of them are in the oceans. So we have a lot of completely submerged or partially submerged volcanoes. And we just know a lot less about them because they're harder to look at, harder to monitor, harder to get to, harder to even know where they are. So most subsea volcanoes are probably unmapped, and we don't even know where they are, let alone anything else about them.
So, what are some repercussions from this? Like you just mentioned a volcano eruption in Tonga. We feel these. They're not just things that happen in the ocean. I mean, a lot of the times they can be, but we feel these every now and again, correct?
Yeah, we do. So it's been really interesting the last sort of 10 years as publicly available satellite data has become a thing, because we used to not know really when volcanoes in the ocean had erupted at all, unless they impacted on land. And they impact in lots of different ways. So you can have big, huge eruptions that produce tsunamis. This is what happened in this Tongan eruption. Luckily, the tsunami wasn't too big, and this volcano was only partially submerged. So we knew where it was because the top of it sticks above the sea, and it had erupted quite recently. So we knew where that one was, and we had some idea that it was likely to erupt again in the future, although it wasn't really monitored at all. But for a lot of volcanoes, if they lie completely underneath the ocean and they don't produce, I don't know, a tsunami, or we get things called pumice rafts, which is where you get floating rafts of lava. So really, really bubbly lava that's so light that it floats on top of the sea. And those can be a real pain. They can fill up. So they're bad for boats. Obviously, you don't want to sail your lovely yacht into a load of pumice, or even a big tanker. You get tankers where the water intakes suck in the pumice and then it makes their engines overheat and stuff. So that's bad. Where the eruptions break the surface, you can get big eruption columns, which are a problem for aircraft. That's pretty well known. And then there's all the normal sort of repercussions of ash and stuff if they break the surface. You also can get hazards that are sort of not as obvious. So there are several regions in the ocean where volcanoes are thought to have erupted when vessels were in the area, and we didn't really know what had happened, but the vessels just disappeared. And some people think that if something blows up underneath your ship, it's not going to be a super great situation. But also you can get degassing of volcanoes, which can reduce how buoyant your vessel is. So if you have water that's full of gas bubbles, all of a sudden things that were floating won't float anymore. So they have really variable hazards. And until we had satellite coverage, we didn't really know where eruptions were happening unless one of those hazards had hit human populations. And now we have a better idea. So we still don't have 100% coverage in high resolution of the Earth, but usually if there's a decent sized volcanic eruption in relatively shallow water, we'll see it now from satellites. Now in deep water, that still isn't the case. So if you've got a volcano that's at several thousands of meters, you're very, very unlikely to have any kind of impact. There are a few sort of like freak volcanoes. There's one called Havre, which is near New Zealand. And it's at like 1,000 meters and it still managed to produce a pumice raft. And there's a really great group of people working on that, trying to figure out how and why that happened and the processes that caused it, because it's very unusual. But usually in deep water, even with satellites, we wouldn't know that eruption has happened because you just won't see it at the surface. Now, luckily for us, very, very deep water eruptions usually aren't too hazardous. They could be. I mean, you could have a very large landslide in deep water that could potentially, I don't know, displace water and cause a tsunami, but it's very, very unlikely. So most of the hazards are associated with volcanoes that are shallower. But again, even those aren't well mapped. So there are quite a lot around Japan, around Tonga, where we don't really know how often they erupt, how much of a hazard they pose, that kind of thing. And a major eruption at one of those volcanoes, like that was just demonstrated in Tonga, can have really, really big impacts on coastal communities in the region. And at the moment, we tend not to monitor them, which I mean, it's a real bugbear of mine that we sort of just ignore them. Because when you have a volcano on land, if you have a city nearby or people nearby, or even if you don't really, but definitely if you've got populations, near to it, you're going to have dedicated monitoring facilities. So you're going to be looking at how much the ground is moving, how it's shaking, what the chemistry of the gases coming out of it are, how often it's erupted in the past, where those lava flows have gone, whether or not it had explosive eruptions or effusive eruptions, those kind of things. But even if you're just a little bit offshore, so volcanoes that are very, very close to shore, we don't have any of that information, and none of them are monitored, really. I think there are two, and I mean, not even proper, but two proper-ish subsea volcano observatories in the entire world. And when we think that a huge percentage of our volcanoes lie underwater, that's an incredibly low number when, like, compared to things that are on land.
Only 2? Where are they located?
So one is in the Pacific and the other one's being developed on just off Santorini.
Okay, so we have like 1.5.
Yeah, yeah, exactly. There may be others that I'm not like aware of, but there are certainly not very many volcano observatories for volcanoes that lie underwater. And there are entire regions where we don't have any monitoring whatsoever. We tend to rely on seismic for subsea volcanoes, and they'll often tell you if something's erupting, but the coverage is really, really patchy. And it also really depends on whether or not the countries around that area are set up or are able to maintain seismic observatories. So, you can install a system somewhere, but if there's nobody to go and maintain it, or if there isn't, I don't know, a university department that are interested in that, or you don't have the right skill sets in that area, those observatories will just fall into disrepair. So there are large regions of the ocean where we don't have good measurements. And that means we can only detect quite big earthquakes using stations much further away. But volcanoes are often preceded by quite small earthquakes. Yeah, so an eruption is usually preceded by small earthquakes, not by big earthquakes. You can get big earthquakes, but mostly small ones. And so if you only have a seismic coverage that can hear something big, you're going to miss all of that information before the eruption happens and potentially not get any warning whatsoever. And then these eruptions are really unpredictable. So Hunga Hapai, which is, it's not a mid-ocean ridge volcano. This is an arc volcano and therefore more explosive than we'd expect.
It's a what volcano?
It's an arc volcano, so it's produced at a subduction zone rather than where the plates are moving apart. They're moving together. And in those areas, you get different types of volcanoes there because where one plate is being subducted, you're driving a lot of material off that as it goes into the mantle. And it means that the magmas are more complicated and they tend to contain more what we call volatiles, so more water, more carbon dioxide. And these are the kind of things that drive explosive eruptions. So you tend to get quite sticky magma that's hard to erupt, but that's full of bubbles. And when they sort of expand, when you depressurize that system, those bubbles expand explosively and you get a really big explosive volcanic eruption. And that's much more typical in subduction zones than it is in spreading zones. You do get explosive eruptions in spreading centers, but not as often. So yeah, when you can have those big explosive eruptions, we might have no warning whatsoever that they're going to happen. And where you've got water as a component, they're even more unpredictable because when you have hot things meeting water, you flash that water either, at depth as supercritical fluid, but in shallow water, you flash it to steam. And when you get steam, you've got expansion. So you start to increase the explosivity of an eruption because of its interaction with the seawater, as well as just the expansion of the bubbles within the magma that's driving it. So these eruptions are really, really unpredictable. These volcanoes that lie underwater are really, really unpredictable, and we don't really monitor them. And I think that's a massive gap. And it's logistically very difficult to monitor them. That's why we don't do it. I think that's something that we probably should start thinking about doing.